Hello everyone. Well, today I begin this session with a small but powerful quote. Self-development is the best medicine for achieving success. Now, you give yourself so much time to improve that you hardly find time to criticize others. In doing so, you'll be developing not only yourself as an individual, but you will be able to achieve success faster than the others. We are actually discussing over here in this session about force. In this lecture, what we are going to do is we are going to talk about the definition of force. We are going to talk about the factors which affects force, right? And we'll be beginning this session right now. When an athlete wants to throw a very heavy ball during shot put contest so that it may go as far as possible, he has to push the ball hard. We say that the athlete applies a large force to the ball to make it move through a large distance. Similarly, when a person wants to draw water from a well, he has to pull the rope attached to the bucket full of water. We again say that the person applies a force to the rope attached to the bucket of water to make it move and come out of the well. When we want to open a door, we have to push the door handle with our hand. And when we want to close the door, we have to pull the door handle with our hand. This means that to move an object, it has either to be pushed or pulled. A push or pull on an object is called force. The direction in which the object is pushed or pulled is called the direction of force. We open or close a door by applying force. When we push the door to open it, then we apply a force on the door in a direction away from us. And when we pull the door to close it, then we exert a force on the door in a direction towards us. Forces are used in our everyday actions like pushing, pulling, lifting, stretching, twisting, and pressing. For example, a force is used when we push or kick a football. A force is also used when we pull a door. A force is used when we lift a box from the floor. A force is also used when we stretch a rubber band. And a force is used when we press the brake pedal of a car. The fallen leaves of trees fly away with the wind because the force of wind pushes them away. Even the roofs of some huts fly away during a storm because the force of strong winds pushes them away. And when we fly a kite, we can actually feel the force or push of the wind on it. An interaction of one object with another object results in a force between the two objects. In other words, a force arises due to the interaction between two objects. At least two objects must interact with each other for a force to come into play and show its effects. If there is no interaction between two objects, no force can show its effect. Suppose a man is standing behind a stationary car. Since there is no interaction between the man and the car, no force acts on the car, and hence the car does not move. Now let us suppose the man pushes the car with his hands, due to which the car starts moving. When the man pushes the car, there is an interaction between the man and the car. During this interaction,
a force arises which acts on the car and makes it move in the direction of applied force. Well, we must note here that the man has to push the car to make it move. Here, the two objects or things which are interacting for the force to come into play and show its effect are the man and the car. An adult man can apply large force on an object, whereas a child can apply only a small force on an object. This means that a force can be larger or smaller than the other force. The strength of a force is expressed by its magnitude. The magnitude of a force is expressed in the SI unit of force called Newton, which is abbreviated as capital N. 1 Newton is the force which can make an object of 1 kilogram to move at a speed of 1 meter per second. Along with the magnitude of force, the direction in which the force acts is also to be specified. This is because if the magnitude or direction of the applied force changes, the effect produced by the force also changes. When two forces act on an object, then two cases arise. Either the forces act in the same direction or the forces act in the opposite direction. If the two forces applied to an object act in the same direction, then the resultant force acting on the object is equal to the sum of the two forces. In other words, when two forces act in the same direction, their effective magnitude increases. This will become more clear from the example that I'm going to cite now. Suppose there is a heavy box which one man can move only by pushing it very hard. Now, if two men push this heavy box in the same direction, it becomes much easier to move the heavy box. This is because when the two men apply their forces of push together on the same direction, the two forces add up to provide a much bigger force, and this bigger force can move the heavy box very easily. If the two forces applied on an object act in the opposite direction, then the net force acting on the object is equal to the difference between the two forces. In other words, when the two forces act in opposite direction, their effective magnitude decreases. This will become more clear from the example that I'm going to cite now. Suppose there is a heavy box lying on the ground. Let the two men push this box from opposite direction, one from the left side and the other from the right side. Assuming that one of the men is stronger of the two and applies a larger pushing force than the other men, we can say that the box will move in that direction in which a larger force is applied by the stronger man. The box will, however, move very slowly in this case because the net force acting on the object, that is the box in this case, is equal to the difference in the magnitude of the two forces applied on the two by the two men. And this net force is actually very small. If the two forces applied to an object are equal in magnitude and act in opposite direction, then the net force acting on the object is 0 or nil. Since the net force acting on the object is 0 or nil, in this case the object does not move at all. It remains in the same position. For example, if the two men push a heavy box from opposite direction by applying exactly equal forces, then the heavy box will not move at all. It will remain where it was. A familiar example of this case of equal forces acting in opposite direction is provided by the game called tug of war. In this game, two teams of persons pull at a rope in opposite directions. Members of both the teams try to pull the rope in their direction. When the two teams pull the rope equally hard, the rope does not move in any direction. At this point of time, the two teams are applying equal but opposite forces to the rope, due to which the net force acting on the rope is 0 and hence the rope does not move. Actually, the equal and opposite forces applied on the rope cancel each other's effect. Ultimately, the team which pulls the rope harder by applying greater force wins the game.
So we had just discussed about few things about force. We have tried to define force. We had also talked to you about what are the factors on which force is depending. Let's learn this through our mind map. Before I get into mind map, let me tell you what is a mind map. Mind map is something which helps you in recalling the concepts that you have learned. It happens that at times when you go to school writing your exam, during the exam there are few facts that you know, but when it comes to the exam hall you might not recall at the right time. So here we are giving you an option how to recall it in the exam hall and score better marks, right? See, here the central theme is force. I hope this is understood. This is the central theme, the force. Now from here, just like in a tree, there are branches that comes out which bears fruit. Over here also you have one branch which talks about push or pull on an object. If you remember, we have defined force as push or pull on an object. Another concept that we have talked about over here is if force is applied in the same direction. If you check over here, if it is applied in the same direction, then the resultant force is the sum of the two forces. We have explained this. When I'm talking about the resultant of the two forces, I mean we have to add them up. That is what I mean over here by the word sum. If the object is moving in the same direction, I mean the force is applied in the same direction, then the speed of the object also increases. This is also mentioned in one of the branches. If you see, the next branch talks about if the forces are applied in opposite direction, then what happens? If the forces are applied in opposite direction, then the resultant will be the resultant of the two forces, that is the net force, right? It will be the net force, and the speed of the object actually decreases because two forces are acting in opposite direction, and if they are acting in opposite direction, what would happen? One force will be nullifying the other, or it will be cancelling the effect of the other. We have another thing that we have, if the forces that are acting in opposite direction is equal, if they are equal in magnitude, then what would happen? Then the net force will be 0. So this is a way of remembering the thing in a manner which gets into our system very easily. What would happen? What is basically the magnitude? The magnitude, when I say, that means it is the strength of the force. So in this topic that we have discussed in this lecture, we have tried to cover up these parameters. What I have done, I have given a mind map for that, so that it's easy for you to understand the concept.
So this brings us to the end of lecture. Well, before I sign off, I would request you that in case you have not understood as part which you need to be clarified upon, you can always write to me at sanyal.shankha@gmail.com. Well, those who are already writing to me, thank you for writing. Those who are yet to write to me, please do write. Thank you so much.